So, hi everyone, I guess we can begin. Thank you all for coming to this session. My name is Alina Yurenko, and I'm... Thanks, friends. My name is Alina, and I'm a developer advocate for GraalVM at Oracle Labs. And in this session today, we will talk about how you can use GraalVM, and more specifically, the native image component of it, and how you can actually use it to take your applications to production. So testing, monitoring, actually developing your applications, everything you need to know to work with real-world applications. And Sebastian here yesterday was trying to convince you that maybe you shouldn't use native image. So let's see if I can convince you today otherwise. A few words about myself before we actually start talking about GraalVM. So as I said, my name is Alina, and that is my Twitter handle in case you want to ask a question or if you have some feedback. And I work at Oracle Labs, and we are this cool R&D unit at Oracle where we are doing a lot of research. GraalVM is probably one of our biggest projects, but also we are doing research in areas such as security, programming languages, machine learning, all kinds of things. I love both programming and natural languages, and I understand Polish quite a bit. So if you want to try talking in Polish to me during the breaks, I will be happy to listen to you. And I'm also Ukrainian, and what you can see here on this slide is my beautiful hometown, Lviv. Since we're in Krakow, I assume some of you have been to Lviv already, and I hope that we can meet there again someday soon. So let's talk about GraalVM. And one of the things that I like about it as a project, but also that is a bit confusing for people from outside, is that it's huge and there is so much in it that sometimes it will be confusing when I should use each part of the project and how do I use it the best for my particular application. That's why in the session today, I want to focus on what GraalVM can do for Java, and then specifically on the native image part of it. So before we go into the native image part, I just want to quickly mention that GraalVM is also a full-blown JDK. So you can use it the way you would use OpenJDK or wherever is a JDK distribution of your choice. And that is shown here on the slide on the left. So you can just replace your JDK distribution with GraalVM, and it will work out of the box as expected. You will get access to all your tools, libraries, IDEs, wherever you like. And in this mode, it will use as a platform your normal hotspot VM. The only thing that will be different is that we will replace the top-tier compiler, the C2 compiler, with our own Graal compiler that has several new additional optimizations developed by our team. So even in this JDK scenario, you can see significant performance improvements by switching to GraalVM. But that is the JDK, and today I want to talk specifically about native image. And that is the part of GraalVM that allows you to take your Java application and compile it ahead of time into a platform-specific native executable. And the reason why you would do so is because this native executable will be fully working, fully functional on its own, and it will not need JVM anymore to run. So you can deploy it on a machine that doesn't have a JVM on it, and this application will be fully functional, fully working on its own. And since in this mode, GraalVM is working as an ahead-of-time compiler, so it's the same compiler, but it can also do ahead-of-time compilation. All this compilation is happening at the build step of your application development process, so it no longer needs to happen when you actually run your application. And many apps will benefit from it because most applications are started way more often than they are built. So if you can do all that work at the image build step, rather than every time that you are starting it, you can save a lot of time and a lot of resources when your application is actually running. And those benefits of native image, so fast startup, low memory footprint, were recognized by many frameworks and tools and libraries in the ecosystem. That's why all those frameworks that you can see here on the slide, they're commonly used to build microservices with Java. They all adopted GraalVM as a platform. So how is it even possible to take something so dynamic as a Java application and compile it ahead of time? So what is happening when you run the native image command from GraalVM and give it your Java application is the following. At the build step, we will look at your application, and we will try to find all the reachable code starting from the main entry point. So we will look at your app, look at the main entry point, and then from there, we will try to find all the code paths that are actually executed and understand what your application is doing so that all that code gets compiled and put into that native executable, but the things that you are not using will be eliminated so that we can produce this fast, lightweight version of your app. So that's one part of the story. That's ahead of time compilation, but there is another one, and that is initialization of your app at the build step. So we will also try whenever possible to initialize your app at the build step and produce a pre-populated version of your application heap so that your application can start much faster with this pre-populated heap, and this way not to do that work once again at the image runtime. And if you compare those two modes of execution, so if you compare running on native image versus running on the JVM, so it can be GraalVM, OpenJDK, whatever, you can see that in terms of startup time, those are quite different. Because when you run application on the JVM, there are many steps that need to happen before your application reaches its peak performance. You would need to load the GVM executable itself, load classes, start interpreting, profiling, compiling, and then eventually, when your application warms up, it can run with the best peak performance. Now, with native image, so with the ahead-of-time compilation, since we've done all that at the image build time, all we have to do is load the application, and it comes with pre-populated heap, and then you can start immediately run with optimized, compiled machine code. So this is startup time, and often I hear that, okay, startup time is great, it's obviously a benefit of GraalVM Native Image, but what if I don't care about startup time because I have a longer running application? And here I would argue that memory savings could be probably even more important than startup times, because indeed many applications run for long time, so maybe startup time isn't so critical. But memory usage and resources usage in general, especially if you're deploying your applications to the cloud, are always important because those define the cost of your deployment. So if you compare running on a JVM versus on native image in terms of memory usage, you will see that to run on a JVM, you need to keep around memory for all that code execution infrastructure, while on native image, since there is no dynamic code execution at runtime, you only need memory for the application itself and for its data. And then when you decide to scale such applications, those differences become even more significant. So when you're scaling your application running on a JVM, you are most likely also scaling resources that are needed for this code execution infrastructure, while on native image, you only need to scale, in this case, memory for the application payload itself. OK, so let's say it sounds interesting and you want to try building such application yourself. Where would you start, and what would be some good tips and tricks to use? The first recommendation I want to give is to use our build tools. So that is Maven and Gradle plugins coming from our team. The latest release is 0.921. And those will help you build, test, and in general develop applications such as native images. And they also offer out-of-the-box support for JUnit. So if you want to build such a project yourself, my first recommendation would be start here with those plugins. OK, enough with the slides. Let's see those plugins in action. So what I have here is one of the applications that I want to show to you, and specifically I want to show how we would test such an application. So here's my Java application with tests. And this is my application class, which is fairly trivial. And here's my calculator that has this methods add. And we have some tests in place that are making sure that our calculations make some sense. And when I look at my POM.xml, this is the part that I'm interested in. So this is my native Maven plugin coming from GraalVM build tools. So let's see if we can test such an app. What's interesting, let me just put this higher. Here I can see this big and maybe a bit scary native image build command. So it's passing a lot of option and configs files. But to me, I don't care much about it because for me, it's abstracted away by the build tools. So all I'm running is just Maven test command. So now it's building my test in the native image mode. So as the part of this process, it will also produce a native executable version of my tests. OK, now our build process is finished. And as a part of that build process, it also ran my test. And it printed out this report of each of my tests. So we see that all of them are passing, and they are all successful, and this all happened in the native mode. But also, if I want to verify that this is exactly a native test, so as a part of this build output, native image also shows me which artifacts were produced and where they are. So I can just go to that file. That will be target native tests. And I can execute them directly, and I'm getting the same output. So this is indeed showing that my tests were compiled and executed as a native application. OK, and another helpful thing in terms of testing is that recently there was this announcement from the JUnit team that they introduced 2 new annotations that are specific to native image, so enabling or disabling native image testing that you can use for your classes and methods if you want to test your application in the native image mode specifically. So we looked at the smaller app and how we can test it using build tools and how we can test it in general in native image mode. So what if we want to test something a bit more advanced? Let's say our application is using some external dependencies, maybe a database, which is often the case, right? And we want to test how our application is working with the database in the native mode. So my recommendation here would be to look at one of those frameworks that we saw on one of the previous slides that support native image. And most of those frameworks, if not all of them, offer some kind of native testing support out of the box. Here I will talk about Micronaut test resources, but there is also similar functionality, for example, in Quarkus, and there it's called Quarkus Dev Services. So Micronaut test resources is this module of Micronaut that helps you test against external dependencies, and it will handle provisioning and lifecycle of those dependencies for you, so that specifically for development and testing purposes, you don't need to do this manually. And let me show you how we would test such an app. OK, this is this one, and I just want to give credit. So this module and this demo that I will be showing was created by my colleague, Cedric Champeau. So thanks to Cedric for this great project. So what we have here is a list of books that we want to store in MySQL. Let me just get here. Yep. So we want to store those in MySQL, and we also want to make sure that it works correctly with the database. And for that, we have this test in place that is testing, trying to put another book in our database and then read those books. So this one I already have compiled because I'm mostly interested in the outcome of the test, but I will show you what was happening here. So here we are running our Gradle native test command. There is some intro work happening, and we are mostly interested in this part where test containers kick in. And yeah, one thing I wanted to mention is that Micronaut test resources, among other things, are using test containers as well as Quarkus Dev Services. Any people here in the room who like test containers? OK, quite a few. My friends at test containers will be very happy to hear that. So yeah, this is the part where test containers kicked in. They provided that MySQL container for us. We tested against it, and our test result says that we have ran this test in the native image mode. We talked to this MySQL container, and it was all successful. So if you want to test such application, I would suggest that you look at the framework support and what kind of native image testing support they provide from the framework side. OK, so we looked at testing, and there is another thing you need to be kind of aware of or know how to work with if you want to work with GraalVM Native Image. So did somebody here in the room hear that GraalVM doesn't support reflection? OK, fewer people, but still some. So this is not true. GraalVM does support reflection. And now I will tell you how exactly and what you need to know. So one, as I mentioned, GraalVM is a JDK. You can run applications on GraalVM as a JDK. In that mode, reflection is not an issue. It works exactly as on any other JDK. But if you're working with native image specifically, things you need to know. So this ahead-of-time compilation process that native image performs happens ahead of time under a closed world assumption, meaning that everything there is to know about your application needs to be known at the image build time. So those more dynamic Java features, such as, for example, reflection, they pose a bit of a challenge for native image because compiling things ahead of time, it's pretty much impossible to know what will be happening at runtime. And that can be handled, but for that, your application might need some help and some configuration. So how do we approach it? The first thing is that native image, when it builds your application, it knows about reflection, and it will try to figure out some more obvious, more common reflection calls on its own. That is one part of this support and how it's working. Another thing is that native image also comes with this tracing agent that can observe your application behavior and output this configuration for you. So it will produce configuration files that native image can then pick up and automatically use when it builds your native image application. So those things will be configured automatically and will work as expected. And the last thing that can be helpful there is that when libraries, frameworks, etc., ship this reflection metadata within their packages, that is also helpful because native image can pick up this configuration and use it to build an app that is aware of this reflection usage in your application. Let's see if we can build such an app and configure reflection working as well. So here's another demo that I have, and let me just go to my application class. So here we are, and what we are trying to do here is we are trying to access this message field coming from its message class, so the one over here. And if you go back here, you can notice that we are doing this maybe in slightly less obvious or common way. And the reason we are doing it so is for demo purposes, so we can try to kind of confuse and outsmart native image just to show you how we can configure it. Because if this was done slightly more kind of in obvious and common way, native image would figure it out automatically. So this is just for demo purposes to figure out how we can configure working with reflection. So this is my application, and now I will try to build it as native image and see if this part will be working. One more thing I want to do before I do that, so I'm going to my POM.xml, and this is the part coming from native build tools, and this is my native image tracing agent. So it is set to false. Let's build this app, and let's see how it works. So do we have any guesses? Would this compile or not? Come on, you can try to guess. No. OK, any more ideas? So it compiled. Let's see if it's working. So it's in target directory, and it's called example app. And we are getting this message saying that reflection is not working. And that message is the one coming from here in case when it's actually not working. So let's see if we can fix it. I will go back to my POM.xml. I will enable my agent. So this is saved. And actually, let me check one more thing. So this is my target directory, and this native folder is for the configuration files that native image will be using. So this is my reflect config, and this is empty at the moment. It's all good. And one last piece of the puzzle is I have this agent script, because I don't want to type all of this. So when I run this, let me just move this higher. When I run this, it will observe my application behavior on the JVM. Let me just open this file again. So it will observe my application behavior on the JVM, and it will produce configuration for me. I don't know if you noticed, because it was super fast, but this file was empty before, and now it has the config in it. So this is configuration that is needed for that particular part of application to run. Let me try to build the app once again. Now it builds, and if you pay attention to the native image command, it's now slightly longer. So among other things, it's also passing the path to my configuration files. So now that it has agent enabled and it has configuration in place, it can build the same native application but aware of this configuration. So let us run the app again. And now we're actually getting that hello native message coming from here. So this configuration file might look trivial now and as something that you probably, worst case scenario, could do manually. But as your application goes bigger, this tracing agent could be really helpful to automatically reproduce that configuration so you don't need to do this kind of thing manually. Two things to be aware here, though. So when you're running the tracing agent, it's always a good idea to execute as many possible code paths when you're running the agent, so it can observe all the scenarios of how your application can work and produce configuration for all those scenarios. That is one thing to keep in mind. And another thing, though it's very helpful, just to be on the safe side, you might want to take a look at the tracing agent output and make sure that the configuration looks complete to you before you start your build. But in general, it's quite helpful to produce this configuration so you don't need to do it manually. OK, so that was reflection. And what about reflection in third-party libraries? So one thing is your own application where you developed it and you know exactly what it's supposed to be doing and how it's supposed to be using reflection or other dynamic Java features. But what about third-party libraries? And is there a better way to handle reflection in those? There is indeed, and there is a decentralized place on GitHub that was created by our team, and it's now being developed by our team and our community. And this is the place where various community members, framework teams, library teams can centralize, like in a centralized manner, put configuration for native image so that other users can reuse it and have it automatically discovered by our native build tools. So let us see if we can use this library to pull configuration for our app. And for that, I have yet another app over here. And this one is trying to use H2 to put some customers in the database and then to read them. And let's look once again what is happening in our build file. So this is my native Maven plugin configuration, and I'm mostly interested in this part where this is specifying whether or not we can access this centralized repository with configuration for native image. So let's say I don't know about this part, it doesn't exist. Let's try to build this app as is. OK, so what about this one? Would it build or not? Yes, I like how people are more optimistic now. Now I think you're closer to the right answer. What's also interesting, as you can tell, this app is not so huge, right? But even that app, as a part of build output, native image is showing you the results of the analysis. And even such an app has around 10K classes that became reachable as this app is built. So sometimes we get this question why the native build process is not so fast, especially for bigger apps. But the thing is that there is a lot of work to be done to take something like a Java app, which is big and using a lot of dependencies and including dependencies on the JDK. So to take something like that, analyze it as a whole thing, and then optimize and compile it. But our build is finished, so let's see how it's working in the native mode. And it's failing. And who doesn't love it when native image, when live demos fail? And it's failing, and the reason why it's failing is showing us over here that it cannot figure out how to work with H2. So let's see if we can fix that. Let me just go back to my config. And notice how I'm not specifying any specific config here. So I'm just putting back this configuration part where it says, OK, I know that there is this repo. Go and try to discover this reachability information for me. So now that this is in place, let's try to build it once again. OK, and as it's building, once again, if we pay close attention to the native image build command, we can notice that, again, the native image command slightly changed. So now we can see this repo being used as a part of this build configuration command. And we even see that it's picking up, so it's discovered, and it's picking up config for H2. And we even see a specific commit in which config for H2 was committed to this repo. And while it's building, I also wanted to show you this config repo closer. So this is the repo, this is the folder that contains the actual config, and here you can see config for all kinds of things. So what do we see here? There is Netty, there is some JNA config, there is Tomcat, all kinds of things. And if you go back, it's a kind of big community project that we introduced recently, but we already have a lot of contributors. So if you ever build and produce configuration for some tool or library, consider contributing into this repo so that other people can automatically reuse it to build their own applications. OK, our build should be finished now. All good. And let's try running it again. And now we see a different output, right? So we managed to successfully insert those customers in a database and then read from it. And once again, notice how I wasn't specifying any configuration on my own. I just said that, OK, I know that there is this repo. Go and try to find configuration for it, because those two projects, build tools and this configuration repo, are integrated together, so build tools can discover configuration coming from this repository. OK, and let's talk about performance. So native image is really great when it comes to startup and low memory usage, but what about peak performance? Because we've heard this many times that JVM is great, and we really know that it is great for peak performance because it executes code dynamically, and having access to that runtime information and profiling information, it can optimize your application on the go to adjust to application behavior and all the other factors that are involved, and then optimize the application for the best possible peak throughput. And what about native image? Because it compiles the application ahead of time, so it cannot exactly be aware of what is happening at runtime. So here on this chart, what we are looking at, this is from a while ago, but this is still valid to illustrate this point about different execution modes. So the green line, that is executing your application on a JVM. Then yellow one, that is native image in a kind of basic computation. And the red one is native image with additional optimization that is called profile guided optimization. And you can see that in the beginning, JIT kind of starts slower because it needs to warm up, right? But then over time, it warms up, and then it gets to a really high peak performance. And then native image in a basic kind of configuration, it's good. And another thing that I like about it, it gives you predictable performance. So another way to call it is instant performance. So from the very first seconds, in even milliseconds, your application performs on a high level, but maybe not on the best possible level. But when you add profile guided optimizations, it becomes even better. And the way this works in practice is that native image compiles the application ahead of time, so it doesn't have access to profiling information. But it's possible to handle that and to work around that if you, once again, observe your application behavior on the JVM, collect that profile information, and then you give that profile information to the native image at build time, so it can kind of combine the best of both worlds. It will compile your application ahead of time, but it will also use this profile information that is coming from runtime, so it can ahead of time compile your application, being aware of what your application will do at runtime. So if you are using profile-guided optimizations, you can reach comparable performance in terms of peak performance on native image comparing to running on the JVM. And talking about performance of native image, another thing you would be looking at is GC options available. And by default, in native image, you get serial GC, but there are a few more options as well. So there is an epsilon GC in case you basically don't need to perform any GC at all. And if you want to optimize for, again, the best possible peak performance, then probably G1 GC would be your best shot. I do recommend that you check it out. So if you want to optimize for the best peak throughput, you would need to experiment, but most likely the best combination would be using native image with PGO and with G1 GC. And in terms of monitoring, so what you can do with native image, this is in some aspects work in progress. But one thing that we have in place, and we are actively working to develop it even further, is GFR support. So this is something where we specifically also getting a lot of contributions from the community. And right now, you can build a native image with GFR support. And many GFR events will be already available as you are working with such a native image. And we are working to extend and add support for more events with every release. And a few more things for, again, when you are taking your application to production and you want to maybe optimize it to the best possible level in all the aspects. So it could be the reason that you care about the packaging size. So how big is this final produced native executable? And since it's a native app, you can use a tool called UPX that will compress your application and will make it smaller. So here on the first example on the left, we see a Spring Boot app that was taken down from 66 megabytes to 17. And if packaging size is something you care about, you can use something like UPS to compress it. Be aware, though, that if you're using more aggressive optimization algorithms, this can have runtime impact. So as many things, it's once again a trade-off. So do you want a smaller packaging, or do you want the best possible runtime behavior? This is something you would need to figure out for yourself. And then when we are talking about deploying your applications, there are a few more things that you can do. So with native image, you can build either fully static native images, so with no external dependencies at all. Then you can just use in a Slim or from scratch containers, and they will be fully functional on their own. Or you can use those so-called mostly static native images that will be statically linked against everything except for libc. So this will be provided by the underlying runtime. And those are the deployment options that you can consider depending on what you want to achieve. So here, for example, we want to show you how you can go to the smallest possible deployment image size. And here we gradually go from red, that is on the JVM, to green, which is on GraalVM Native Image, and then gradually optimizing and taking it as small as possible. And then in the very end, so this is a very basic Java Hello World app, we are taking it down to almost 5 megabytes for the image size. So that is in the from scratch container and compressed. That is as little as possible. So again, if this is something you want to optimize for, consider applying those optimizations. And one more interesting thing about native image, which I think is not talked about enough, but I personally like a lot, is the security aspect. So as we said, native image is being compiled ahead of time at the image build step, and this means that there is no new arbitrary code execution at runtime. It may be seen as a limitation, but I would say it's rather a design choice. And here, specifically from the security perspective, it's beneficial because everything that is in the native image was proven to be needed at the image build step. So there can be no additional new code execution at runtime, which I think you can agree is additional kind of security level and measure. So only code that was available and needed at the build time will be included in native image. And another interesting thing is that only the code that was there at the build time, but also that was proven to be necessary, will once again be included in native image. So native image will eliminate at the image build step all the code that you're not actually using. So it will strip away all those parts of your dependencies that are not actually needed for what your application does, and then only the things that are explicitly involved in your application functionality will be left in this native executable. So as you've seen, reflection by default is disabled, and to work with reflection, we would need explicitly enable it either ourselves, or this will be provided by framework or tool, but by default, it is disabled. And same applies to serialization, deserialization, so this once again would have to be configured, but again, from another level, it adds additional security level to your app. And one more interesting thing, so some security vectors, specifically around just-in-time compilation and just-in-time compiler, are not possible when your application is running on native image because there is no just-in-time compilation happening at runtime. So all those attack vectors simply become irrelevant. OK, and what is new? So a few new things that are in GraalVM. Recently, there was this announcement from the IntelliJ team that they are working to add debugging of native executables right in IntelliJ. So this is very exciting, and we are waiting for more updates from them to become available. And in terms of monitoring, there are also some new things that we introduced in the last release. So one is we added this more granular support for specifying what kind of monitoring you want in your app. And we are working to keep developing those monitoring features even further. And I want to show you very quickly one way to monitor such native image applications. And for that, I have here my JWeb server, which is additionally compiled to native image, because why not? It's a Java app, so we can compile it to native. So here it is. It's in native image mode. And I can just run it as I would run any other native image app. It starts super fast. And if we go to this URL, it doesn't do much, but it's serving the current directory, working as expected. And this was built with JVM stat support flag passed during image build time. So I can also monitor this app in GraalVM. So here it is. If I go here, this is my simple web server running, and I can see how it's doing. And if I go back and maybe send some more requests to it, I see application kind of monitoring and reflecting what is happening with my application at runtime. And one more thing I can do here is I can take a heap dump specifically from here. And now when it opens, I can explore my heap, and I can also see some information about the system that my app is running on. So for example, this is my macOS. I'm using Java 18, and I'm using GraalVM 22.3, which is the last released version. So this is one way to monitor such applications, and we have some cool updates in the upcoming release in June. So stay tuned. And one more things that are recently announced. So we have JDK 20 builds available as dev builds. So again, the release will be in June, but if you want to use them, we have those available on GitHub as developer builds. And if you want to see what is happening next, we are also an open source project. So we have our community roadmap on GitHub. There you can see some of the things that we are working on, what is coming up next, and participate and join the discussion. And one of the things that I couldn't resist to mention is that in this next release that we're expecting in June, we are also working to add ZGC support on Hotspot VM. So that will be working in GraalVM JDK in the JIT mode. But this is coming up soon, so really waiting for it and can't wait to try it out. And what is next specifically for native image is a number of things. So we are working on making more libraries compatible with native image so that all the libraries that you want to use will be working out of the box as expected. For that, we have the centralized repo in place, but also we are working with manual library and framework authors to make sure that those are working correctly as expected out of the box, so you don't need to produce any configuration from your side. We are also working to reduce build times and memory requirements, and those gradually go smaller and smaller. So since recently, you can also build simpler apps, for example, I think on GitHub Actions, where you can limit the memory to something like 2 gigs or 4 gigs, and those will successfully build as well. And we are working to improve peak performance of native image in all the aspects. So looking at that from the compiler side, looking from the GC implementations, improving existing ones, and planning to add new ones. And to get started, how would you try it out on your own? The way you can get GraalVM builds, probably the easiest way is to use this shell script that I have over here. Or if you're using GraalVM, if you're using SDK-man, there is also a way to get GraalVM builds from SDK-man as well. So to summarize this, GraalVM is a high-performance JDK that you can use as your normal JDK to run Java applications in JIT mode. But also you can use the native image part of it to produce native executables that are fully functional on its own, no longer need JVM, start really fast, use very little memory, and there are tools that we have that will help you build, test, and deploy such applications. That is all. That is my name, and that is my Twitter handle. And I've been told that we can use Slido to do Q&A. So let me see if I can find the right tab. I think I do. Yes. OK, I see questions. So how to speed up build process? So that's a good question. I skipped this update this time because this was from a few releases ago, but there is this one flag that you can pass. That is -OB, I believe, but you can also Google it as GraalVM Native Image Quick Build Mode. And this flag will speed up the build step. It will not become like 10x faster, and it will only affect the compilation step. So there are other steps in the native image build process, but you can speed up at least the build step by doing this step, by passing this flag for quick build. And another thing, so it's also kind of related to the next question, for some frameworks, and for example, Spring Boot as well, they have this mode of like AUT mode, I think it's called. So in that mode, you can run your application as it would in the native image mode, but on a JVM. So they will apply similar restrictions, but and they will optimize your application. They will generate code, generate config, will let you validate some kind of behavior that will be working in native, but you can do it on the JVM. So to summarize that first question, try that quick build mode that is passing the flag, and look at the framework support. Most likely they will have some kind of AUT on the JVM mode in which you can validate at least some of the native image behavior. But just to add to it, so regarding the build process, obviously you need to build your application to validate how your application is working. But in general, it's our recommendation that you build to native as more or less last step in your application development process. So you don't need to do it on every single minor logic change, especially if that's around your business logic. So you can do it once in a while as you're getting closer to deploying your application, but it's not mandatory to do it on every single minor change. And about Spring Boot, yes, and let me actually illustrate it super fast because that's very exciting. So if you go to start.spring.io and you start configuring your project and you add dependencies, the very first thing you see here is GraalVM Native Image support. So this now works as of, I think, 6 months ago, out of the box for all Spring Boot projects. This is how you can enable it. Genuine tests are supported. How about Spock tests? Are those supported as well? I would need to look at that. I remember that there were some issues. To be honest, I cannot say right now. I think there were some challenges. I'm not sure if those are already solved or not, unfortunately. Can you use native agent with feature toggled code? Should I enable, disabled all feature toggles once agent is monitoring? So I'm not sure what you mean by feature toggled code. So do you mean features that are from native image, or do you mean something else? If you could just come to me afterwards and talk a bit more about your use case, I would be happy to answer. So how does the central metadata repository handle configuration differences between versions of dependencies? Good question. So if we look at this repo, let me just super quickly open it. There is configuration for each of those. I don't know, let's look at H2. And there is version specified here. So I think by default, when we pull dependencies and we pull config from this repo, we specify minimal version that is supported. So long story short, this is specified in those config files in this centralized repo. OK, where was it? Did I close the tab? I think I did. I don't see. OK, this one. Does it work with Lombok? No, I don't think it does, unfortunately. And when it's better to not use GraalVM? Oh, it's my favorite question. My answer is always use GraalVM. The question is which part, right? So as I said, you can use GraalVM as a JVM. And in that scenario, there are no obstacles, there are no migration issues. It's super easy. So you can always use GraalVM. The question is which part of it. But to answer your question seriously, I mean, it depends on what you want to accomplish. I would say that if you care about peak performance the most, then the easiest thing to do for you would be to use GraalVM as a JDK with the GraalVM compiler, and that probably will be the best possible scenario for the best peak throughput. Now, if you care about startup, if you care about memory usage, if you care about packaging size, then native image is the best. And as I said, we are working on a number of things to also optimize the native image peak throughput. So we are very optimistic about native image catching up very soon in terms of peak performance with the JVM itself. So there is really no reason not to use GraalVM. As a maintainer of open source library, how should I ship reflection configuration with the lib or in the repo or both? So preferably, you will shape config with your library. That is what we recommend, and that is the best for your library's users if it's shipped directly with your library. If for some reason it's not possible, you can contribute to our repo. We welcome that and we encourage that, but still it's more of an intermediate step, and ideally that config will be available with the libraries. It will be the easiest thing to do for your users. Is there any production running big project on GraalVM? Oh, that's the kind of question I like as well. So I will skip the parts where people run on GraalVM as a JDK because I can assume you're asking about native image. So one is Alibaba. Anyone here ever used AliExpress, something like that? So that is running on GraalVM. There is a blog post they published about it. And recently also Disney Streaming published a very cool blog post where they were trying to reduce AWS Lambda startup times and memory usage with native image. And I think they improved memory usage by, I don't know, some crazy numbers. I wouldn't find them. But Disney Streaming are running huge workloads on native image on AWS. So I think that's a big enough project for you. Can I use GraalVM on prod on my company for free? Yes, you can. There are two versions of GraalVM. I did not get to that part, but if you go to downloads here, there is a community version that is fully free, open source, licensed under UPL. You can use it for free, no problems, no issues. Even Twitter was using the open source version for many years, no problem at all. And then there is enterprise version, which you can use for free on OCI if you are a JavaC customer, or you can use it for evaluation, testing, development, this kind of purposes for free as well. And then for production, commercial kind of use, you would need to get a license. OK, and what else? Are there any plans of introducing parallel GC in community GraalVM version? There's actually a very interesting GC contribution that is being reviewed right now. And I think it's a really late stages. So I'm hoping it will be merged really soon. And I'm monitoring that closely. I'm very excited about that. So I hope we will have it available very soon in native image in community version as well. Does it work with Kotlin? Yes, GraalVM does work with Kotlin. Will the examples used in this presentation be made available somewhere? Good point. Usually I made a GitHub repo. I don't think I made one this time, but I will create it and I will put my slides there and I will tweet the link to it. Okay, so I think we are almost out of time. Yeah, I do want to answer this last one. So why is the version 0.9? I was asking the team the same question recently as well. So this is not GraalVM. This is native build tools. So Maven Gradle plugins. I would say they are ready and stable, but we are still making significant changes there. I think we will release 1.0 fairly soon. You can use them. I know companies that are using them in production right now. It just means that specifically with native build tools, so Maven Gradle plugin, you might need to update once in a while when a new version comes up, but that's not like every week or every month. It's more stable than that. It should not be a concern, I think. OK, now I think we're running out of time, but I'm here until the end of the day. So if you have any other questions, please feel free to ask me. And with that, dziękuję and talk to you later. Thank you.